Good afternoon. My name is John Brown. I am a certified geek. Certified in the sense that my shrink is still seeing his shrink, but that's okay. I work for a company called Chagres Technologies. We're a consulting firm, blah, 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 shameless plug at the end. Basically, this presentation is about traffic engineering 101 for small and mid-sized providers. Sort of set the expectations, or try to set the expectations. I'll back up a little bit and give you a brief overview of who I am. For the last 5 or so years, I ran an ISP out in the middle of nowhere. We served a couple different states, provided mostly business connectivity, etc. Given the recent economic times of the world, I don't do that anymore. Part of that was our decision, part of that was just market forces and changes there. The one thing that I noticed when talking with a lot of providers is that most small providers are pretty much busy just trying to figure out how to keep the network up, keep it running, throwing T1s in, or if you're a little bit bigger, maybe some T3s in to keep traffic going, and just basically keeping the network running. Not spending a lot of time figuring out where their traffic is going to or from, things along those lines. So I sort of have this personal interest. It's been a pet hobby of mine while I was at this ISP that I worked for and was part owner in, to figure out what our traffic was and to try to have a better understanding of that. And what I want to try to do today is to try to convey some of those things that we learned, some of those tools, some of those ideas, and try to basically stir up some thinking within providers about that they should really be serious about traffic engineering. Now, most of the time when I talk to a small provider, they think traffic engineering is something that's left only for the big boys, the EUNets, the Sprint, the Global Crossings, the whomever, cable and wireless, etc. And there's not really anything they need to worry about because, gee, they're just running T1s or a couple of T3s, and they're on the sticks and no real big deal. I think that is such a wrong mindset, and that's another reason why I'm here today, to try to talk a little bit about you need to get out of that mindset and you need to think about figuring out where your traffic goes. So in essence, to sort of set the expectations for the presentation, we're going to talk about a little bit about what this talk is. What is traffic engineering? Why should you care? What are some of the tools that are available today that may not have been available, say, 12 months, 18, 24 months ago? And I think there's been a lot of development in tools and code out there to help that. Generally some things to think about in your network and within your organization. And then I want to open it up to questions, answers, comment, feedback amongst the chairs, get people talking in the room about what they're doing, what they're having problems with. There are people in this room that are writing tools. There are people in this room that are thinking about writing tools. I'm sure they'd be interested in hearing what you would like to see. So I want to try to stir it up and get folks chatting a bit. Part of this also is that sometimes traffic engineering is thought about as there's a geek basis only for it. So from a business perspective, a business decision maker within your organization may or may not understand the value of figuring out what your traffic flows look like. Why should you go buy that $2,000 Pentium box and stack of RAM and so forth, put Cflow on it, get all this stuff running? What benefit is there as far as a business? We're going to talk about that as well. Again, geared towards a small, mid-sized ISP. For ISPs that haven't done this before, some things about how to get started, helping smaller providers build better net. And I'm interested in this as a series of ongoing talks, not just a sort of a one-time, we're going to be here once, and you'll never hear anything more about this at Nanog. I'd like to see if there's feedback or if there's interest in people having further sessions like this on Sunday. Sort of, today is 101, and we're summer or something right now, so maybe fall we're 102, or what have. Is there a value in doing that? Here's what I'm basically calling traffic engineering. It's the ability to understand your traffic flow. Okay? It's the ability to figure out where your traffic is going to and from, how many traffic TCP sessions are being set up, being torn down per unit of time, how many of them are up and stay up for a long period of time, what's the impact on your network, understanding how packets move around the net. One of the things that I have found in talking to a lot of small, mid-sized providers is the concept of asymmetry in traffic. Global net routing is not something that they solid have a good feel for, and I want to try to help answer that a bit. With traffic engineering, you also want to try to figure out what your traffic UDP, TCP, ICMP, etc., what ports are being used. We'll go into this a little bit more in detail. What AS pairs for endpoints. You know, let's say you're transiting, pushing a lot of traffic to AS, what is it, 6461 I think is above net. And you happen to be somewhere where above net is, just to sort of pick on them for a moment. Would it make sense to push that all across your UUNet or your Sprint connection? Or if you can drop an Ethernet and get peering up with 6461, that might help offload some of that transit traffic that you're spending money on. Traffic flows. Traffic flows in two separate directions. We agree with that? And then there was silence. And on the sixth day, God rested. No. Okay. Inbound, in other words, people are pulling traffic from the net. How many of you are networks that are substantial end user basis? A lot of home users, DSL users, business users. Okay? So as broadband goes out there, you're finding more and more people probably pulling a lot of stuff off the net from content providers. Outbound traffic, how much of your traffic is being pushed out to the net? When I ran this ISP, we hosted a large newspaper, in our region at least large, website. All the other ISPs came to us for that traffic, so we were pushing a fair amount of traffic out. And it was good to be able to sit back and look and see what that traffic was. Asymmetric flow. What is your flows like to and from the net? If you are multi-homed, you may be finding yourself in an asymmetric situation where traffic going out, let's say your UUNet connection, is returning on your Sprint link. And people may be bitching about the UUNet connection when in reality it's a Sprint connection problem, or vice versa. And again, I'll use real live, honest-to-God providers, but I'm not picking on anyone specific. So don't go shooting me for that. And then last, on your traffic flows, are you more pull or are you more push? If you're a content provider, what are you? You're pushing more stuff out to the net to the people that want it. If you're an ISP that's in Santa Fe, New Mexico, and you've got 5,000 dial-up users and 300 DSL users, you're pulling that traffic into the net as more. Asymmetric flows. Traffic leaving takes one path, traffic returning a different path. This can cause problems. Just a quick sort of beat over the head. Remember the traffic tests things both ways. TraceRoute.org is your friend. With traffic engineering, you can help determine what protocols are being used. UDP versus ICMP versus TCP. Okay. Keep in mind that TCP session-based. So that means it requires a certain amount of, if you will, back channel for those ACK packets. And if, let's say, you're pushing a bunch of stuff out, but your inbound to your network is completely saturated, those ACK packets are going to have a hard time getting back in, which may impact your ability to push stuff out. So you want to be able to understand what your flows are in and out. Things you can also do, K1 Wireless, actually Internet MCI a long time ago had this tool. It was a DOS, denial of service attack detector, basically. And it worked off of a very early version, I believe, of Cflow and some other scripts, and it would sit there and look at the traffic, and it would see whether or not there's potentially, you know, an ICMP flood, etc. So you can use this stuff, these tools, to be able to determine whether or not you have a denial of service attack happening. Very recently, I got a phone call late in the night from a particular provider talking about a client that all of a sudden went to 15 megs worth of traffic in 2 shakes of a stick. They were able to see and know exactly where that traffic was syncing based on the fact that they were running some of these tools to monitor their network. And they stayed on top of that. With some of the things, you can automate that. Instead of having to look at the pretty pictures, you can sit back and have it generate a script that if traffic exceeds a certain amount over a period of time, that it sends off some sort of an alarm. What ports are being used? If you're using things like Cflow, FlowScan, etc., you're going to be able to determine what ports on your network are being used. This can be very important. Let me ask a question here. Raise your hand if you are currently running your own Usenet news server. Okay. How many of those people, how many of you are taking a full unfiltered Usenet news feed? Okay. And you're taking binaries and all of that. Okay. Cool. The rest of you, I guess, are either A, not using news, or B, you're buying news access from somebody else. How many of you are buying news access from somewhere else? Okay. Let me ask, why are you buying news from somewhere else as opposed to running it inside your network? You raised your hand?
Too much traffic.
Too much traffic? To run it, to buy it from somewhere else as opposed to running it?
Full feed, too much traffic.
Full feed, too much traffic into your network. Okay. David?
Hardware management.
Hardware management. Other words, grab one out of the sky. No. Hardware management actually and server management is actually a big deal. Who can quote me what the current full newsfeed volume is?
It's on an average of 280 gigs per day.
280 gigs per day. So if you wanted to have 7 days of spool, you're going to need a whole buttload, which is a unit of measurement we use out in the middle of nowhere, of disk space. But one of the things to think about is, yeah, there's the hardware management issues, there's the transit volume in, but you can sort of mitigate some of that with the folks like Akamai and Sidera and the other satellite feed vendors. They seem to be doing a pretty good job of pushing news down. But if you sit back and look at the amount of articles that your users are using and determine how much of that news is repetitive traffic coming in, you might be able to turn around and justify the cost of the hardware or the software or this $200 a month for whatever it is Akamai is charging these days for a satellite dish, or Sidera, for a news feed. And then to keep those articles local as opposed to having that traffic repeatedly transiting across your link. But the same with FTP or the same with web. You can sit back and look and see whether or not things like caching, is it really helping you? You know, when you turn the cache on, does the amount of traffic I'm pulling in HTTP-wise from the outside go down? Does it stay the same? Does it go up? And try to tweak your configurations based on that. You can also, on the previous slide, you can also, the other point I want to make was, you can also look and see whether or not you're pushing a lot of web traffic or you're pulling a lot of web traffic. If you're ending up pushing a lot of web traffic, that might mean you've got a number of users on your network that have websites that are very, very popular. Or you could have just gotten slash dotted. And having your network get slash dotted is interesting. Because you watch all of a sudden all this stuff, people coming in, requesting data, and all this stuff going out. And you may not have the capacity, or you may want to know why other things have slowed down. AS pairs, end-to-end, I personally, and I think there's religion on this, I personally like to look at traffic based on source, destination, endpoints, AS-wise. If I'm pulling a lot of traffic, and at our highway, I think we were pulling close to 30% of our stuff inbound was coming from AboveNet. So one of the things that to me was to sit down and figure out how can I get better connected to AboveNet at a lower price so that I don't have to sit there and be pulling that across my expensive transit provider links. Could I go peer with them somewhere? Could I preference that traffic coming in from one vendor versus another? What could I do to help improve my connectivity to them? It's also useful with regards to peering. In New Mexico, all the ISPs are sort of these little autonomous islands, and they don't talk to each other. And so what we had to do, and we brought up private peering sessions, was we had to go over and sort of say, see, look at all the traffic you're pulling from us. Or in some cases, see, look at all the traffic we're shoving to you. Or we're taking from you. Wouldn't it make sense for us to bring up a frame relay PVC between us, or if you're in Albuquerque, a point-to-point circuit, or something so that we were not going out to LA? Well, here's the real path. Most providers out of New Mexico would go to Phoenix, Phoenix to LA, LA to San Francisco, hit an exchange point up there, hop over to one of our providers, come back in through Denver, Dallas, Albuquerque. That was so we could send email across the street. That doesn't make sense. For $40 a month, I can turn up a frame relay PVC between two Quest-based connected frame relay cloud-connected ISPs, and we can push our traffic locally. So by being able to see the AS endpoints, I can go and look up those endpoints of my top talkers, and I can sit there and go, AS 11711, I'm pushing a lot of traffic to you. You're down in Alamogordo. Why don't we do something in-state and bring our connections that way? Okay. It can also help you figure out where to buy transit from. If you're pushing a lot of stuff to and from, and you look at the AS path, and most of it happens to be going through, let's say you're connected to 701, and all of your traffic is going to some AS, and you go look that up, and you start looking at the AS paths, and it's 701, 1239, and the customer. Gee, I think you should be getting some connectivity, buying or whatever from 1239, and looking at that. Or maybe when you decide, wow, our connection to 701 is soaked, we need to add more bandwidth, maybe it makes sense to go and add bandwidth and make that purchase from 1239 as opposed to more 701. As a provider, why should I care? Improve your connectivity. And that can be a whole range of things. Reduce hop counts or reduce latency. If you have to, again in my example of 701 to 1239 to some endpoint AS, if you're having to go through all of AS 701's network to get over to 1239, that's a lot of hops. If you can bypass that and hand it straight to AS 1239, then you're improving your network for your customers. You're making your network better. And more importantly, the best network testing tool, which is actually better than Keynote, is Quake. If your Quake ping times are there, and you can drop your Quake ping times, your customers are going to love you. I didn't see that many people chuckle. Either you're all still asleep, my jokes are bad, or there's a much better conversation going on IRC. Pardon?
You put Quake people on ATM service. It helps them.
It does.
Double their pay times.
I had some circumvention over ATM that just, for the hell of it, too. You can also reduce your costs. You may be stuck in a contract with a particular provider paying gobs more per month per megabyte, and if you determine that you've got a lot of traffic that's going to a new provider, you may be able to leverage that business-wise and get a cheaper transit connection. So this can be real dollar impacts of being able to know where your traffic is going. And that falls into the purchasing choices as well. You can see problems. You can see all of a sudden very quickly who that bad rogue co-location server is in your network. And yeah, you could use something like Mrtg, and we'll talk about that in a moment, and you'd see Mrtg, and you'd see your switch traffic, and you'd see that port went way up. But you wouldn't know much more than that. And you want to, let's say, go figure out exactly what kind of traffic it was. Well, if you're using something like Cflow and FlowScan, you can turn around and see exactly what port and what volume of traffic, and whether it's TCP, UDP, are they doing an ICMP flood, are they doing a whole bunch of TCP traffic, what are they doing on that port, and go filter accordingly and be more specific, have a finer granularity to it. You can also use these tools to write your own scripts to determine whether or not there's a denial of service attack going on. I think it would be better if you got a page, or if I got a page, or whoever, that 2 in the morning that said, hey, this port just exceeded these parameters that we set, there's potentially a denial of service attack going on coming into our network. You can find out about it before your customers start complaining an hour later or a half hour later, or if it's business customers in the morning. You can already be working with your provider to try to get that filtered upstream, or to try to trace it back, or whatever. And yes, I do encourage transit providers to work with their customers and help solve denial of service attacks. Any questions or comments so far? Going once, twice, snoozed. Tools. These are the common tools that I used. And I had a couple little Perl scripts and a few other little things on the side. Mrtg, good stuff. RRDTool, Cflow. I'm assuming that's still a good address to get Cflow from. Okay, C-A-I-D-A. Sorry. Microsoft spell check didn't know that. I think we need to go and re-educate the libraries. FlowScan. You can find FlowScan off of the RRD page as well. And I'll pop that up in a little bit. Rancid, I forgot where the link was for it. It's, I think, Shrewsbury, something. Jim Heasley and crew, I believe, but you can find it through Google. If somebody has it, I saw a hand go up. If you want to spit it out, go for it. Shrubbery.net? Okay. Mrtg, when this first came out, I was just a happy little clam. Really, I was. Because here's the ability to sit there and, at that moment, track how many dial-up users are hitting my PM3s, and whether or not I was getting busy ports or what have, and then how much traffic was being used. It uses SNMP, Simple Network Manglement Protocol. Yes, I know there's some people think SNMP is the gift of the world. Uses definable scripts for non-SNMP devices. So if you happen to want to do things like disk space or CPU load times or what have, you can write scripts. If you can output 3 or 4 numbers to Mrtg, you can sit there and shove anything into this you want. Okay, so very flexible. We expanded it to look at our mail queues. We set up some scripts that if our mail queue got above X, it would send off an alert saying, hey, wait a minute, your mail queue is somebody just blew up their mail server and we're spooling a whole bunch for some domain. We can go find out what happened and try to let someone know. Or we just got a big dump of spam or something, someone figured out a way of getting in. Use the latest version of Mrtg. There's a big change from sort of the old version that everyone's set up a year or 2 ago versus what's there today. And I'll tell you about the number one problem I had with Mrtg. Every time you rebooted your Cisco router, your interface names changed. And so then you had to go in and rebuild all the bloody configs, to write some scripts to rebuild the configs to make sure it hit the right ports and blah, blah, blah. The new version of Mrtg uses RRDTool, and we'll talk about that in a moment. And Mrtg becomes a front end effectively for RRD. And the neat thing is that the new version of Mrtg, instead of using the SNMP interface names or OIDs, it actually will use the IP address on the interface or the description name that you put on there, something that's a lot more static. So if you insert a card, remove a card, add more PVCs, whatever, those ports and configuration graphs that you've already got built stay the same. So life is good. and basically solves the changing interface name problem, as I call it. RRDTool, round robin database tool, I think is the close enough name for it. There are too many TLAs. Everybody know what a TLA is? Three-letter acronym, okay. I view RRDTool as sort of the next-gen Mrtg. The other thing that Mrtg used to do is it just built this big, huge file of values. With RRDTool, it builds a round-robin queue, so big, and it just fills that queue and it rotates around, shoving values into it. So you get a static file size for your database objects. Mrtg becomes a front end. So you have RRD back here managing the data itself, and Mrtg is pushing stuff into it or putting stuff out on the display. I think RRDTool is much more flexible than Mrtg. There's a lot more front ends and scripts available to use RRDTool data. Your data sources become unlimited. If you can write a script to shove the data in, pull it from wherever you want, push the data in, you can put it there. Yes, sir?
Because the Mrtg uses RRDTool, now you say RRDTool is more powerful than Mrtg is not understandable.
Yeah, basically, I think I foibled a little bit. Mrtg becomes a front end. So you've got, what happens is if I remember it correctly, Mrtg, all of the stuff was all shoved in basically one package. What's happened is we've split it apart, so RRD manages a container full of data, and Mrtg is a front end that reads that data and deals with it. That's, the new version has a compile option. You can say, I want to build Mrtg, but I'm going to use RRDTool. Okay, hopefully I didn't butcher that too badly. When using Mrtg, do the version that does RRD. Cflow. This is another one of those apps, when it first came out, I just went, ooh, yummy. Because what's cool about Cflow, and I didn't know about Cflow until I read this option in Cisco, about I could go spend gobs of money and buy this Cisco software and be able to use these NetFlow packets that the Cisco box could shove out at me. And I looked at the price of the Cisco software and I was like, ooh, ick. So I scoured the net looking for something open source-ish, free-ish, less expensive, and stumbled across Cflow. The original version of Cflow is completely different than the current version of Cflow in a way that it handles data and does things. And there's sort of a mindset difference that you have to think about when you go between the two. I'm not going to go into so much of that detail because today I would just tell you, go get the latest version of Cflow, compile it, compile arts, et cetera, and enjoy. I am sort of being risky at putting up there that Juniper puts this in there. If I remember reading specs somewhere, Juniper does output some sort of flow statistics. Is that correct? Okay, good. And as you can tell, my bias as to who I prefer as far as boxes. The neat thing about the flow statistics is that you'll get source and destination AS numbers. You will get source and destination IP numbers for each packet that's going through. Source and destination port, in other words, IP port, not physical interface port, but IP port. You'll know what protocol is being used, packet size, which physical interface. The thing that it does not do is it does not collect payload data. So you're looking at the envelope, but you're not looking at the contents of the envelope per se. All right? It's just grabbing that stuff off the top, shoving it out on a UDP port that you configure on your box, and then the collector, you have this collector machine that sits there and collects the data. Okay? And you can set up multiple collectors on your network and have those aggregate back so that you're not having to sit there and transit. If you're running a fairly large wide area network, you're not having to transit all this collector data back across your net.
Tracks with GSRs, that's particularly good in bottle GSRs. You can't do the full NetFlow sequence. You need to run get samples rather than full feeds. Okay.
The other thing I will add also on that is that with current, how would one say, unique challenges with current versions of iOS and Ceph, you may experience some problems collecting full or accurate amounts of data as well. So check the version of iOS for this hour and go from there. I know a couple of boxes that are running Steph that are giving the relative data is correct, the actual numeric volume, the number being passed out is wrong on the packet sizes and a couple of other things. And then there's another version of iOS I know on a different customer's network. It's not even giving them AS numbers once they upgraded from one rev of 12 something to a new rev. Yeah. And then we have just some general Ceph bugs that cause boxes to melt. So, RRDTool, Cflow is nothing but a collector tool. It sits in the background. It's a daemon that sits there and grabs data, shoves it into some sort of container for you to go deal with later. What I have found to be a cool way of dealing with it is a front end to RRDTool called FlowScan. Okay? And so what FlowScan will do is it'll sit there and read data from Cflow, punch it into RRDTool, and then allow you to display pretty pictures. Pictures like that. Okay, this is from the University of Wisconsin wisc.edu site. And you can sit here and see, and camera guys, I'm going to go towards the screen if you wanted to pan or not, or do you care? Okay. You can see, they're trafficking on this particular picture. They're saying how much of our traffic is coming from ResNet or from computer sciences or other campuses. They've broken things out sort of geographically within their network, and they're plotting that up on the screen. I'm going back towards the stage. The big picture here is really cool because if you look at the bottom, there's how much of this traffic is HTTP. The bright red is HTTP. The bright green is FTP data port. The purple, as I wander back over here, this purple here, that's Napster. So I guess their rate limiting is working. But it gives you an example of being able to see where and what kind of traffic is going across your net. And you can make intelligent decisions then about what you want to do with your network. If you've got a customer, a business customer, that doesn't want their users using Napster or whatever, or is really interested in knowing about what kinds of traffic is out there, you can give them information like this, and they can see what's going on.
It doesn't seem to be anything with the rest.
The rest is the non-solid line at the top, the purple line. This is total here, okay? And so the delta here is sort of everything else that they haven't specifically stated. This is based on bytes in and bytes out. You can also look at the bottom picture is by flow. In other words, when a TCP session is brought up and people transfer data back and forth, that's considered a flow. And when that session is torn down, that flow goes away. Okay? And so you can look at the number of sessions that come up and down, up and down. And that might be able to help you figure out whether or not you might be running into some sort of a problem on a server that's not allowing you to have enough connections up and running. You'd see a lot of connections attempts coming in, but nothing actually being built. You can compare that against, say, for example, your packet I/O. FlowScan is flexible. You can create graphs to represent different data views of the net. We created graphs that had us as RAS as a source, and then our top 5 ASs that were destination for our traffic, and then the flip-flop of that, what are the top 5 sources of traffic for us coming into our AS? And we would plot that on a pretty picture, and we could see who was pushing or pulling traffic from us over the course of a day or a week or a month, and get a feel for where our traffic was coming or going. Ports, protocols, AS pairs, I think I've bashed that one into the ground pretty good. Rancid. While not necessarily directly traffic engineering, as we start to build bigger networks, as we certainly start to roll out broadband technology, DSL, etc., and we have to build up numbers of PVCs and particular configuration options for each of those DSL users that we put out there, depending on how you're implementing DSL within your network. You get to this point where instead of having a Cisco 3600 or a Cisco 7200 or 7500, one of them in the rack, and this little config file that hardly ever changes, you're now at a point where you have a number of boxes in your network where the configuration files become more dynamic. Someone's touching that config, either a human or a script, on a daily, hourly, some basis. And so there's got to be some way of capturing that information and putting it in some sort of version control so that if you booger it up, you can roll back to a previous rev, pick that up, and rebuild your network. Yes, sir?
Sort of a wish list, but you can tie that easily with just log messages as last user change on the config and use that as a trigger even to run a rancid dump. Right. I suggested that a couple times, but that would be easy tie with CVS.
So what Rancid allows you to do is it allows you, it's a set of scripts that knows how to, if it's a Juniper router or a Cisco router or something like that, it knows how to basically telnet or SSH into the box, do a show run, pull that down, stuff it in a CVS file, and continue on. And you can set how often you want it to go out there and hit the box and check for configs. Now what it will do also is that if the config hasn't changed, then it stays at the previous rev. There's a nice little CVS web interface that you can download off the net that will sit there and allow you to go look at that CVS file and see any version and see what the changes are in a sort of a pretty color format. I actually don't remember off the top of my head, but I can look it up for you. Okay. Think about many smaller providers are at the point where adding another T1, just adding another T1 isn't a hot idea. Don't get into this situation where we'll just go buy another T1 from our current provider, plug it into the router, and magic will happen, and I'll get good traffic, and my customers will stop complaining. That's a short-term fix. That's a quick and dirty. You really need to, I think, today sit back and look at what's your crossover point from getting away from DS1s to buying a T3. I personally believe if you're pushing more than 4 or 6 megs of traffic, it's DS3 time. There's a lot of benefit for that. Instead of inverse muxing a bunch of T1s, or instead of doing some BGP load sharing round robin packet sending of a bunch of T1s. Specific case, we had 4 T1s to a particular upstream, and I won't mention them to protect the guilty or innocent. And then we got rid of those, and we added a DS3 to the same provider. The perceived improvement as far as just lag or latency on pushing stuff back and forth. When we went away from those 4 T1s, which we were doing a little BGP load share across them, we went to the DS3, life was significantly better. And we were able to negotiate with our provider in such a fashion that that DS3 circuit loop cost really wasn't that much more than what we were paying for the loops for 4 T1s. Okay. DS3s are coming down a lot. In 1 second, Trace. They're coming down a lot. So you should be able to, quote unquote, buy transit from the big guys at under, I would say, $800 per meg per month. Certainly on DS3 circuits. And if you can't, talk to me. I'll tell you what I've been getting quotes for that I do not sign NDAs on, and you can use that info to go beat up your salesperson.
In making the transition, John, did you use Cflow D for capacity planning?
Yes.
Part of the analysis?
Yes, we looked at the data, and we were able to sit there and figure out sort of project where our traffic was going. And part of the decision was, we're here now. Yeah, we're at 70%, 80% of capacity where we are today. It's going to go here based on sales and bandwidth over subscription ratios that we had. The quick and dirty was I could make the phone call to the sales rep. They could have another T turned up in a couple of days. But that would just be one of these things that when I got to 7 or 8 or 10 T1s, it was going to be painful and more equipment, more capital cost incrementally if I added it up over a 6-month period. Let's bite the bullet now. I looked at DS3 interfaces. They were coming down in price, et cetera, et cetera. Let's bite that bullet now. And then we went and we negotiated the DS1 because the provider was going to have the same kind of capital expense increasing as proportion to the number of circuits we're adding. So they said, we'll give you the local loop at basically cost from their carrier. Okay.
Similarly, did you analyze any of the Cflow D data to determine if you would need to change your peering and if that would help you cost-wise?
Given that we're in New Mexico, peering is one of those 4-letter words that people go, huh? And if I could ever get Bill Norton to come out to New Mexico and just sort of go around with me and club people over the head and bring them to his little peering bar, I would love to. What we did is we were able to use some Cflow data to go to some of the more savvy providers that were getting it and show them the pictures of the traffic between us and them, and that it made a hell of a lot more sense for us and a hell of a lot more sense for them for us to go turn up a 512K frame circuit between us or a point-to-point circuit. And when we did that, both sides won. At that point, we were hosting a website for a newspaper, the Albuquerque Journal, and so these other ISPs, all these users were going to it, and it made a lot more sense for them to go 2 hops to it as opposed to literally 16 hops, because they would go across their local transit provider out around the world, come back on into us, and as opposed to just going across town. There has literally been probably 6 attempts over the last 4 years to build an exchange there, and the ISP political climate helps prevent that from happening, the distrust between providers. But as far as transit, to sort of answer your question, as far as transit, yeah, we used the Cflow D data to figure out who we were going to go buy transit for, how much we needed. So when we sat down and negotiated with the salesperson, I could honestly sit there and say, here's what our traffic has looked like and our growth has looked like for the last 6 months of the last year. Right now we're here. We're going to get to here, and the trend is already there, and this is where I'm forecasting. So, yes, I believe I'm going to be able to be a 20 meg provider buying 20 megs of transit from you in 10 months or a year, what have. Let's get some good pricing now to get me on board so you got that bigger monthly sales item down the road. Because the salesperson got commissions based on upgrades, upsells to the network. So we played to their sense of greed. Do you know where your traffic is going? It's 10:30 at night. Do you know where your kids are? Do you know where your traffic is going or coming from? If you don't, I think you should. Is your transit provider the best for your traffic flows? If you're pushing everything to Sprint and you're buying from UUNet, that doesn't seem to make a lot of sense. Or vice versa. Or you're buying from some local provider in your community who's sort of the bigger guy locally, and everything's going somewhere else, and they don't have connectivity to that place that you're normally going to. The last line is a bit about traffic engineering, and I'll probably get shot. I know if Jeff Hootson was here from Telstra and others concerned about route table growth, they'd probably shoot me. But I think it's an important thing that the small mid-sized provider needs to think about. Is your IP space yours or your upstream? If it's your upstream and you're looking at traffic and you determine that it's better to go with this provider over here, now you've got a renumbering pain as well. Okay? You're going to have to renumber out of this provider if you're going to dump them, move over to there, and that's a factor. So I encourage ISPs, while maybe not necessarily to go out and run off and go buy, or excuse me, wrong word, please forgive me. Go out and make the appropriate requests with their local registry and get IP addresses if it makes sense. But you should certainly consider that in your network policy and your network engineering and so forth. As an example, I highway started in 1996 when I sort of got whacked over the head by the end of 96 about, gee, having our own IP space made a hell of a lot more sense because we were not tied to our provider. That became a goal within the network to be able to reach that minimum criteria where it made sense for us to get our IP space from Aaron. Okay? And once we did that, we also found our ability to pick providers was much better. We also found our ability to negotiate with those providers to be a little bit better as well. Going out and getting IP space is not for everybody. Not everybody needs it. There are ways of being able to do things without having to have your own provider-independent space. But it's something you should actively think about. Certainly, if you've got the equivalent of a /19 or more worth of space, I think it makes strong sense for you to go out there and look at that. Questions, general conversation. Would like to do is sort of open the forum to allow folks in this room, we've got a fairly good audience in here as far as number of people, to talk about what they're doing. Gentleman here had a wish list item for some stuff. If you've got wish list items, you know, spit it out. Let's sort of mix it up and have a little bit of a conversation. In other words, let's share some information. Okay? And then my question would be to you is something along these lines. This is sort of a feeler presentation. We sort of lightly touched on some of the topics. We could really get in deep. The folks, when I was at the Wright meeting recently, really got into RT config and really went into depth about that. We could get into depth about Cflow. We could get into depth about RRD. We could get into depth about a lot of things. Are these things that are interesting to you? And if there were presentations about this, let's say at the next NANOG, would you attend? And is that something that you're, I guess, generally interested in? So let's just throw that question out to start with. Is these kinds of topics, talking about traffic engineering, figuring out how to push packets around, talking about the problems that you might be running into, is that something you would like to see more in a Sunday tutorial-ish kind of a situation? Yay or nay? Raise your hand if you think this is something you'd like to see have more discussion about and more participation in. Okay. How many of you don't care? Okay. Just wanted to sort of know where the line was. Let's open up to sort of open mic and comments. Yes, sir.
Okay, so we know Cisco only does samples on Engine 2 and Trident cards. So has anyone explored using external collector boxes like the TAP, boxes like the Norris, or NARS, or however they pronounce it, to collect this data on GIGI links in a different manner than directly off your box? Anybody?
Repeat the question for the
Yeah. Actually, what I will do is pass the microphone.
Has anyone worked with these other commercial systems instead of getting your stats directly off the Cisco box? Because there are problems and it is sampled. There are some third-party vendors who will go via taps and get these stats directly off the GIGI link. Is anyone doing that? I know there are products like Norris that do that.
This is being done extensively at the edges for large corporations. So I think the question is,
Well, there is.
can ISP do it in a core in a scalable manner?
You would never want to do it in your core.
I disagree. I think having core type stats is also somewhat useful.
Only if your stats, if you specifically select the data that you're only looking at core level traffic. You really do want to be careful with things like double counting and skewing the rest of your stats by collecting in the core.
I'm from Exodus, so if you look from a data center perspective, it's somewhat interesting to know per data center where your flows are going. And should you get more peering in that data center, or should you let it go to your transit links across the U.S.? For that reason, per data center stats are somewhat interesting in the core, but I understand most people are just thinking edge-wise on this. You can backwards infer from the edge, but...
Well, you can collect in the core, but again, you have to filter your data very carefully.
Okay.
Okay, 1 second, gentleman over here.
Just, when you're on doing the collection in the core, you just need to watch your interfaces closely. As you said, you can very easily get double counting, so you need to be selective on the interfaces you're looking at, because we have that issue because we actually use NetFlow for billing.
Are you doing standalone boxes or are you using NetFlow?
NetFlow.
It just has to be good enough. Is NetFlow and the other Cisco tools, are they good enough, or do you need a lot better?
It depends on what the questions are.
Statistics. In other words, what's the source of the data? What are you trying to get out of it? And how do you represent it, and so forth? I mean, that picture really plays a lot.
Most of us are more interested in a generalized case or in a peering emphasis case, and we're not necessarily interested in specific byte counts, but things like billing and your customers are much, much more sensitive to accurate counting of traffic, and NetFlow does not always lend itself to that.
So that's an interesting question I'll ask the audience real quick. How many people are actually using statistics gathered, be it Mrtg, Cflow, etc., for billing purposes?
Can you separate that from Cflow?
Sure. So we'll break it out. How many of you are using NetFlow statistics for billing? How many of you are using Mrtg 95th percentile type stuff for billing? So it seems like there's a lot more people doing Mrtg-ish 95th percentile than they are NetFlow. Any reason why you're doing one versus the other?
We don't build off Mrtg stuff, so we go off other programs to collect data.
Yeah, 95th percentile, traffic.
Right, yeah.
As opposed to flow count.
What is per interface?
Byte count.
We do byte count per...
Yeah.
Right.
If that's Mrtg or an internal tool.
It's for purposes of this discussion, they're interchangeable.
Where's the data source from? So, do people who do use NetFlow for billing, do you differentiate billing on destination? Are you European or something? Yeah. Okay.
The only reason you would use it, and you probably find that most of the people doing that are outside the US.
I'm pretty sure there's another U.S. provider who
there is,
builds
indeed.
differentiated based on destination, which is supposed to be the end-all pay-for-the-mile thing, right?
For packet, per distance.
God, it sounds like we're back to old long distance where everything out of Omaha was the center of the universe.
Free lunch is over. Okay.
Other questions and comments? Hang on a second. Let's see if...
Yeah, I have a remark. The NetFlow stuff is, some people are trying to get this standardized in the ITF, and there will be a BOF on, I think it's called IPFX, for IP flow export, at the London ITF meeting. And you're all invited if you want to see this standardized. I know that it has become multi-vendor, but it's still Cisco has all the change control and so on. So this might be a possibility to get our, as a community, needs into these protocols. I know, by the way, Foundry is also planning on implementing NetFlow export. I don't know about other vendors.
Which one is it?
Foundry Networks, and probably others too. I also saw like these appliance boxes that you can use for passive measurement. They also can export NetFlow data, and Sun has a server-side bandwidth control system that also has an accounting component that uses NetFlow. So it's really
NetFlow is a product that does that.
Okay. So,
NetFlow? Most of the stuff you can find off CADA under tools. Links to these things.
And a completely different thing I wanted to recommend is Another accounting mechanism that is coming out in several boxes that is Cisco users know this as BGP policy accounting, I think. And this is a very nice system because it really allows you to measure traffic towards a given part of the internet as defined by route maps. So you can, even if you don't have direct routes from, I don't know, say AS 1239 or something, you can, in an incoming route map, you can select all the paths you are seeing with 1239 in the path somewhere, and then you can, this way you can define a bucket. This is then realized as an index, which is actually stored in the forwarding information base in the Ceph table, and you can have a couple of buckets. In the Cisco version, it's 8 buckets, which is a bit low. Juniper has 16, and Riverstone Networks has the same system with 25. But basically, you can define big groups of destinations and account for traffic towards these destinations separately. That's very fast because it's really in the fast path. When you do the destination lookup, when the router does this in the Ceph table, it will automatically receive an index for the destination class. So then it's just a counter increment, and it's very easy to look at these counters using SNMP. So we use this in some places, and it makes life very simple. For other situations where I'd like to use it, there are severe restrictions because of the low number of buckets and also the fact that you can only look at the destination areas. But it's very nice for large-scale traffic engineering and traffic measurement. So Cisco and Riverstone Network call this BGP policy accounting. And Juniper calls it, I think, destination class usage. Very nice feature.
Thank you. Anybody else? I'd like to hear people talk a little bit about what to do with traffic problems. In other words, too much traffic in certain types of situations. In a web hosting environment, for example, you have a customer who doesn't want to pay for more than a certain amount. All of these tools will tell you they're using this much traffic, you can turn around and bill them. Rate limiting, traffic shaping, and so forth. Looking for documentation, ideas, tools for configuring, managing rate shaping. So would you be saying that it would be interesting to be able to say particular customer or particular traffic, if it exceeds some threshold value that you say, to have some sort of a script that adjusts the interface to automatically do the rate shaping to pull them back down?
Either
or base it on
that way, or just fixed in some predetermined max rates. But we have in the Cisco client situation I've got, there's a couple different tools available. We have Cisco Router, which can do traffic shaping, can do rate limiting. The hosts themselves have some facilities for this, and just looking for ideas on which things people are using, where they're getting good results. In other words, rate limiting can have negative impacts on traffic and destroy flows in a lot of ways. So, whereas traffic shaping potentially is better, but has other interesting characteristics. So I'm just interested to hear people talk about that.
Any comments along those lines? I feel like Vanna.
I got a pretty loud voice.
I think that's the problem, though. It's that you don't really need good statistics if there's nothing you can do about it, if you have them. And I think that's what's been going on, sort of, is that people haven't really done a lot, or they're just starting to, really. And then suppose I do get really good statistics, then that other guy's question becomes pretty relevant. So what? So I know I'm having huge problems. What do I do about it?
Are you multi-cloud?
Work for a network management software company.
Okay, we'll pause.
service attacks and things like this and talking to your upstreamers. I know this is a particular problem for us. I don't know what the situation like it is in the States, but I know a lot of times when you report a denial of service to your upstream provider, more often than not, the response is shrug.
That I think represents what happens in the U.S. as well. Am I wrong on that? Okay.
And particularly if you get outside the US, where a lot of the charging is volume-based, they usually shrug and then chuckle in the background because it's all the more they're making out of you.
Ka-ching! But that makes it interesting that you might be able, is there a way of being able to use these statistics to go back to your provider and say, wait a minute, we had something that we didn't want in our network coming into us. Here's the graphic or otherwise data representation of that. We're not going to pay for that traffic. I mean, is that something that you can do into your contracts or not? Yeah, well.
It'd be an interesting contract.
Yeah, it would. I'm just throwing it out there. Like I said, I'm trying to stir it up a bit. I think the gentleman in the back had another. Did you have a follow-up comment?
Yeah. The follow-up comment was, in this particular case, the amount of bandwidth is relatively unlimited. It's in a colo environment, so there's 100 megabit fire hose coming in to a rack of servers. The problem is that the billing is based on anything over a megabit that's used and many different customers served. So we're trying to keep this customer from paying for 100 megabits worth of traffic when something goes on. So this is where I'm looking for ideas on the rate shaping and so forth.
Okay.
They don't want beyond a certain point. So the question is how to best throttle it so that your bill doesn't go beyond a certain point.
Well, the biggest thing I've seen with Mrtg is you can go to your providers and say, at 4 o'clock every day, you guys are pushing half the traffic as these guys. The traffic curve looks pretty stable the entire day. I mean, you can argue with people. Like, a lot of times we're getting billed for stuff we're not using. And, we're using like 64-bit counters. They were only using 32. So, a lot of times you expect fairly large providers to have their act together statistics-wise and actually, maybe tell you when you're getting close, and they don't. So.
Well, I think there's a general scaling issue that the providers are running into with regards to what tools do they use and how do they roll that out in their network and so forth.
So, given that people have a feeling that the large providers don't necessarily have a clue about traffic shaping and tracking, et cetera, do we really want to be billed, or do small providers want to be billed per packet by those larger providers? I mean, is there a demand for that? If we have small providers in here, I'd love to hear an answer to that.
Well, most providers don't. Level 3 is trying to do stuff like this.
Don't have clue or don't want to do per usage billing.
They want to do per usage billing. They want to bill you less if your traffic stays on net, and bill you more if it goes off net. And I don't think they're being very successful. And other providers, I don't think they're monitoring their traffic at all. I mean, we have a lot of different OC3s to a lot of different carriers and DLC and DS3s, and we peg them all the time. They have no clue. They don't know where the traffic's going. It's our responsibility. So if they instituted, paying on a AS destination or off net or on net, I don't think they'd be very successful at it.
What would you like to do?
Keep the bandwidth lower.
So actually throttle the. If they only want 3 megs of traffic, then you're gonna cinch that down to 3 megs, and that's all they're gonna get.
Right. I don't know if that would be the best, but that seems like it's the only opportunity that's out there.
Okay.
What do you want to do that you for that? I think it would be best if the customer would do that. If it's in a colo environment, it's obviously the provider, because you're getting an Ethernet connection on them, and it's up to that provider to rate limit them or do whatever they feel is best. But if it's if you can, if you're the customer and you only want to pay for a meg, and your provider's giving you a 100 megabit Ethernet connection, if you can rate limit that on your servers, you'd be better off than letting your provider do it.
There's a philosophy difference when you take from a colo place. Are you going to put a router at your colo place to protect your equipment and allow you to limit the traffic that you need? Or do you just take a raw port off of his Ethernet network and say, here you go, it's off of his switch and you just feed traffic to it? All of my customers sit behind a router that is of mine that we control, and we control everybody that's down below and what's inside of the colo. And the big providers that are going to provide you an Ethernet port and allow you to run it without a router really want to just collect your money and charge you when the cash register comes in, so they're going to take a limited amount of effort to slow you down.
Right.
I mean, it is not a sophisticated piece of hardware to do some rudimentary forms of rate shaping. I mean, a simple Cisco 3600 with a Catalyst switch will do rate shaping for you just fine and limit you to certain levels. But if you're taking a port from your provider, no offense to the other providers here, you should never assume that your provider is going to limit the traffic to something that you actually want. Yeah. It's your responsibility to limit the traffic that you select and pull down the pipe from that provider.
Yeah. The analogy is complaining to the water company that you're paying too much for water because you have your hose on. I mean, that's turn off your hose and then you won't have that problem. Or watch what you're sending and you won't have that problem.
But I think you run into, I mean, not only what you're sending, but what you're receiving.
Okay, I see what you're
saying. I think the gentleman over here we were talking a moment ago, it would be interesting contract-wise is to, how do you write a contract that says, wait a minute, I shouldn't get billed for that 300 gigabytes of data that just came into my network that I didn't want. Well, I mean, there's that spam, that's denial of service, that's somebody on the net doing something stupid, which is spam, I guess. Pardon?
I mean, technically, whose responsibility would that be if something like that happened? Would that be the provider, or would that be the... You don't notify the provider, it's your problem.
If you notify the provider and you fail to do something about it, I think it's their problem.
So I think it's incumbent upon you. It's incumbent upon you on your end to protect yourself both ways, I think, ultimately is what I would say. I mean, if you don't want that 300 gigs of data that just came into your network and ate up, the 100 megabit pipe or what have, then you should on your side do something to prevent that volume of traffic.
Maybe you could give it back.
Route map, yes, wee-wee.
Something I wanted to actually add to that before was that, and it may come up later in this actual meeting because there's a bit of a topic about it tomorrow, is that if there are better tools out there, either out-of-band tools or stuff that has to be grafted into the router code to help resolve these particular problems, people might be more willing to put effort into resolving these problems.
Tracy?
John, we've talked about traffic characterization tools. We've talked about path performance and device-level tools. You haven't mentioned anything about router performance and routing performance. And this is a question that I had asked you at one point previously about, are small providers interested in the performance of BGP routing? And if you had information on it, could you even do anything with it? Would you? Because that's part of traffic engineering too. So
if I understand the question, in other words, if I'm a small provider, I'm running everything on 3600s, are we basically, I may be oversimplifying the question here, but are we asking, or are you asking, am I interested in knowing whether or not my 3600 is cratering or not? Because
not the box itself, but the routes that you're getting from your peers, looking at peer performance and actual BGP performance.
Okay. I think, honestly, I think a lot of the smaller providers, at least the ones that I've talked to, flight level 350, they're not there yet. Okay, I think that part of it is, and I'm going to be probably slightly unfavorable in the next comment or two that I make, and it's just my opinion and my personal opinion from attending multiple NANOGs for, since Tampa, so however long ago that was. I get the general sense that a NANOG type event is an event that most small providers, their opinion is, it's the big boys only room. It's where the big boys come and play, and there's nothing here that really calls to them to justify them coming over. And I use as an example of that NANOG 19, to which I was the host in Albuquerque, and out of the entire state we had 4 people that showed up. 2 of them from the university, 1 from Los Alamos Labs, 1 from San Diego National Labs. And then there was the helpers that were helping us put on the event, which were from a couple of ISPs. But here was even in townable, in your own backyard, and the 80-some-odd providers that are in New Mexico did not feel that it was a place for them to go to get information or to get education. So there's a part of me that's out on this gig of trying to convince people that this is a place where they should come. It's not just how do we do something new and cool with MPLS, etc. There's a lot of other things that need to be talking about with operators here. And I think it's important because you're pushing broadband and you're pushing wireless out to more of the central part of the country where 6,000 providers live. We're going to care about their traffic, and we need to be able to help them better engineer their networks so that they can push stuff back and forth. They need to be able to better engineer their networks. So I think there's an education process that really comes into, is it a field of dreams, build it and they will come? To some extent, yes, I think so. I think if we had the mechanism or the process, the vehicle to deliver them the education, you'd find a lot more people. When I sit down and I talk about, all right, sort of my BGP 101, where I take a couple of hours and explain to somebody how they can solve some problems or do some things or why they should, et cetera, the light bulbs are clicking on. They've been so busy running a business and running a network and keeping their gross margin there, and the 5 people they have on staff or the 20 people they have on staff, depending on how big they are, that they haven't had time to go look at the new technologies. I know that because when I ran iHighway, I had to pull myself out of the day-to-day grind just to be able to deal with the new stuff and to try to keep up. And there were times where 6 months went by and I was behind. So I think if we had a way of educating, I think you'd find people would be interested in the data. I don't think at the moment they know that they need to be interested in it. Sir.
This is my first meeting, so maybe it's a silly question. In your presentation, the tools that you presented there looked like they were all freely available tools, and so sort of the question is was that because they're the best or because they're freely available? And let me finish. And so, I mean, if there's commercial tools that are good, then, it seems like it should be very valuable, to do those. And it gets back to the whole thing that you sort of allude to of if you do this traffic engineering, you can improve your profitability. And so that's sort of the bottom line. If you can say, do this, here's the savings, or this allows you to do this thing that you couldn't do without this traffic engineering.
To answer the...
With Cisco's flow collection products, you answer the first question very quickly.
Which is open source is better. To answer your question as far as, and first of all, welcome to NANOG. I hope you enjoy the next couple of days, and my advice to you is don't skip out on Monday night bar session. It's probably the best place to get any real work done, and the booze is always fun. But more importantly, I think part of the thing is the tools that I listed are the tools that I was using. I'm a big open source, free, shareware, hack it out myself kind of a person. There are commercial tools out there. Some of them are good, some of them are not so good. As a friend of mine would say, some suck less than others. And I didn't want to get into commercial listing of stuff because I hadn't really used it. I think there are a couple people in this room that represent some of the commercial side of that equation, and they'll probably hunt you down and chat some more about what they have. The last time I did anything commercial was things like HP OpenView Optivity, which was 4 or 5 years ago with when I worked for Bay Networks. And I really could not see myself at that time being a small ISP spending $30,000 on what effectively was a box that did SNMP polls and painted pretty pictures for me on the screen as to whether the thing was up or down. I mean, Big Brother does that, Knuckle does it, et cetera, et cetera. The state of that art has changed radically, and I think that
The cost of the products.
yeah, the cost of the products too. One thing that I would say to those that are in the commercial world is I think there needs to be a rendition of these kinds of products that are economical to the small provider, where it's very easy for them to see, as you said, gee, if I go and do this, I spend this $5,000 on software, and it allows me to save $15,000 over the course of the next year, then potentially that $5,000 was money well spent. If I got to go spend $50,000 and $25,000 in consulting fees, I'm not going to touch it, to be perfectly blunt, as a small provider. Okay, if I'm a UUNet or an AboveNet, Metro Media, whoever, that $50,000 or $75,000, that's chump change in many respects. Okay, Ralph, you had something? Okay. Anybody else have other comments? Yeah.
There's also a distinction between engineering, well, it depends on your scale and your size, but there's a distinction between engineering tools for decision making and
Operational tools.
Operational, and yeah, the billing system should be robust and working all the time. A quick stats collector and some stuff like that doesn't necessarily have to be, full commercial supported by that company, et cetera. Mrtg can get you some good summaries real easily. And you can set it up in a matter of a day or two and try it out for free. So
the other thing to keep in mind is the scalability and scaling of your statistics and other collecting kinds of stuff. Because if you end up having an Mrtg environment and you're probing 8,000 interfaces, are you going to be able to do that in that 5-minute period window? Maybe not. So, you got to be sort of intelligent about how you go out there and probe, and how much of that probing is going to be traffic that you're sort of imposing upon yourself. So, a couple other things. Any other?
MRTG, that's the other reason, one of the other reasons to use the latest MRTG, especially with RRDTool.
Yes.
Is the MRTG, if anyone has noticed, once you load average, like 12 to 14 in no time.
Yeah.
But you need to, and that's no matter how much memory you've got, it's Perl.
Go Perl!
Memory's cheap. Come on, I was able to buy 256 meg sticks, I think, for like 120 the other day or something.
No, the interpreter still beats the machine, though. It doesn't matter how much memory you have.
Also, the Cricket, is anyone... I went with Cricket because they did RRDTool before MRTG did. I'm sure if anyone who's gone back to MRTG after using Cricket.
I've never done Cricket, so anybody else use Cricket? Anybody go to Cricket and then leave Cricket?
Cricket has rounding issues.
The comment from the back is Cricket has rounding issues.
Another sort of operational thing, RRDTool, as far as writing some stuff to get the raw data out, you pretty much have to dump it to ASCII, analyze it, and then if you're do anything with it, you have to bring it back in. Like I was writing spike apps to get rid of bad spikes and rounding issues or whatever. I pretty much had to dump it into an ASCII XML type format before I could do anything with it. Is there anything else out there that can manipulate RRDTool data besides dumping to ASCII? Hashing it yourself. I guess that's a big no.
Yeah. All right. Sort of to round up here, couple things. So if at Fall Nanog, wherever that might be, we were to sort of continue this kind of afternoon tutorial on traffic engineering issues, what would people be interested in sort of diving more into? Just sort of throw out. Yes, sir.
I think it might be interesting to have something you can collect stats off and actually show how to set up bots. Get that out.
Okay.
The last time around, there was Cflow, FlowScan presentation that was pretty good, comprehensive.
But in any case, if you sit down and read through the install docs, you shouldn't really have a problem with it. So I think it should be like 45 minutes.
Okay, so we've got sort of more of a labish, demo-ish. Here we're doing it real. Here's real-time data coming from somewhere. Kind of a presentation.
I'd like to look more into this gentleman's question of no matter what steps you get, accurate or otherwise, what the hell does it matter if you can't do anything about it?
So you'd like to see maybe some more conversation about what do we do with the stuff now that we have it, and what useful things can we do with it. Okay, so that could either be maybe an individual presenter, or it could be sort of a panelist kind of a thing, etc. Okay. Solutions to counter the problems. All right.
You sort of covered a wide range of tool sets. You've included granted, maybe some talk of how those tools can integrate. What other tools are out there that people use? You know, are people using Swash? What things do people use to get that more communicated widely? I think that's good in general.
Okay. Other comments? All right. Well then, here's the shameful plug. Just have to do it, you know. The big thing is if you have, like Ralph said, if you've got problems and solution idea pairs, why don't you dump me some email at that address, john@chagres.net. Chagres, for those of you that care, is the primary river in Panama, Central America, that feeds the Panama Canal fresh water. Everybody always asks me where the name came from. I'm from Panama, so ergo. So go ahead and shoot me some mail. I hope this presentation was enlightening and helped sort of start to focus some light on these kinds of issues. And I thank you for attending. Hope you enjoy the next couple of days. One last comment. Yes, shoot me an email and I'll have it, and I'll also forward it ultimately to Merit probably tonight, so it'll probably show up on the NANOG website at some point as well. Okay? I wrote it, I got off the airplane this morning, wrote it, came here. So that's why it's not there. Thank you.